when you work with FBX assembly from Fusion to TXT, that's pretty much what you got. I use here the Voron 3D printer. As you can see, there is a 5K parts almost. That's pretty much what you would get working with CAD data. It's pretty much as it is when I opened it. I just changed the color using my other tool to take the color from the BSDF and put it into the object color. But except from that, it's pretty much a vanilla FBX object. And so, yeah, you can see here the hierarchy is the same as Fusion 3D, which is the reason why I use FBX, because it keeps the relationship. But yeah, as you probably know, there is a lot of problem. The first one being the scales are all over the place. Especially for the top empty, which is 0.001. I don't even understand why this is the case. This is super weird. And then you can go down the other empty, and they're all 1, 1, 1, 1, which is fine, is as expected. So yeah, obviously as the first object is super small, you can see when the location is not the origin of the world, it seems super far away, but it's obviously the right location. Let's go down to body, and yeah, a body I have no clue why this is the case. Scale 10. I have no idea why. This is mind-boggling why Autodesk made that. There is no reason whatsoever why the scale is 10. So what you want to do in that case, generally you select everything, okay, and you apply the scale. It will work. If it works, it's good for you. It means that you have no instance. If you have instanced the body, it would work because you cannot apply scale of a multi-user object. So this is the first thing my tool here will help to solve as a proof that this is instanced. I just move the pad here, and you can see those 4 guys are the instance of the same geometry. First, you can, during the import, correct the orientation of the main instance. I will, of the main empty. I do it now. Okay, so now the printer is on the right orientation, which is fine. So next, let's see what do we have here. We can obviously apply the scale, that's why we are here, and then we can also apply the rotation. But if you apply the rotation, as you can see here, the origin of this instance is here, and for this guy it's here. So obviously if you apply the rotation, for example, if this instance is the original one, this guy will end up somewhere here. So apply rotation will make all the instances unique. So you will lose all the instance logic. It's up to you. But if you apply only the scale, my system will first make all the instances unique, then apply the scale, and then repopulate all the instance with the original instance. Next, there is some options also for the main empty. You can choose by hand the scale, one being 1 meter. Generally, you want to make it automatic. What happens when you do automatic? The script will find the size of all the geometry inside that has been parented to every geometry parented to the main empty, and will make the size of the main empty, try to encapsulate it as best as it can. Then you can also center the main empty to the geometry, and here not only the size will be respected, you can also center the main empty to the geometry, and if you do that, the main empty will try to perfectly fit the geometry, everything inside. Generally, that's what you want. I don't know what you would uncheck that, but you can if you want. So for example, let's see, where is this empty? Okay, so you can see it's here. It's super small. It's into this mess of empty. The origin of the bed, it is what it is. To me, it's not the best position to work with, but it has its merit. But if you center the empty to the geometry, it will move at the end without moving anything else, and you will have the empty on the center of the physical geometry. Next, you have the child empty base size will resize all the empty that are right under the main empty. So all those groups that are holding the different parts of the machine together, those are the main component. So you may want to be able to pick up visually those guys. So what I did is you choose the size of those empties by setting it here in the slider. The size is in meter, so 0.1 will be 10 centimeter, which makes sense with the size of this object. So let's go with that. Next, the child size factor is each time you go down the cascade of empty, the next empty will be resized by this factor. 0.5 would be half the size of the parent empty. By doing that, we have a visual feedback of how deep you are in the chain of empties. Next, all those first top empties here, you can change the display. And the last empty, the very last empty that is holding the bodies, you can also change the visual display. Okay, so yeah, let's go. You just have to select the main empty, then you click Fix Fusion 360 FBX Transform, and you just wait a few seconds and just let the magic operate. And okay, we have this, which is pretty much what we were expecting. So look at that. You can see where are all the biggest component. Okay. Here you can see the biggest empty is the main empty, and as I said, the instance guy is still instance. So hooray! Let's take a look to the scale. The main empty scale is 1, as it should be by default, and everything has a scale of 1, 1, 1, 1. And also the last object in the chain has also scale set to 1, which is exactly what should be the case by default when you import your FBX from Fusion 360. Next, you can see something else very obvious, that there is a lot of redundancy. So why is there one empty for bed component and another one for bed component inside? You should understand that Fusion 360 component will be treated as an empty by Blender, which makes sense, but you will have a lot of redundancies. So you can go branch by branch, but I will go everything at once by selecting the very first empty. And you just have to next clean useless empty cascade. Here we go. So look at that. Almost 5,000 parts. And when the magic operates, okay, so yeah, we just killed a bunch of useless empties. You can see that bed components are only the relevant component. And that's way more manageable, but still, I'm not done yet. When you have, for example, here, flex sheet, I don't know what it is. Okay, so this is the bed of the 3D printer. Yeah, you can see here, it was a component in Fusion 360 that had only one body inside this component. You understand why Blender understand it like that, but if the component has only one body inside, that doesn't really make sense because the object has its own origin point, so you don't really need to have an empty to put it inside. The next option will correct that. Sometimes SCAD operator will rename the bodies. Here it's called body 1 because it's the default naming system of Fusion 360, but the component has a name. So here you can choose which one you want to keep. You want to keep the name of the object, or you can replace the name of the object by the parent empty representing this component. So yeah, obviously here I want to rename this body 1 to flex sheet, so I will use this function. So same here, you can do it branch by branch if you want to do that, but I will select the main empty to do it to every last empty on the every branch. Let's replace and rename. Look at the number of parts. Okay, so we just killed more than 1,000 empty. You can see here, the path is way cleaner, way more manageable, and way easier to work with. Before that, all those guys were empties with only one object inside, and now instead of the empties, we have the object directly, which makes a lot more sense for this case. Just look at the number. We started from almost 5,000, and we have just less than half of it. I'm still not done. You can also, for example, when you have an empty down the chain that has, okay, so for example here, we have several bodies inside this guy. Let's just take a look what it is. Okay, so yeah, we have one kind of bracket, a screw, and the nut that goes inside the aluminum weighting. Let's put it back in place. So maybe you will be fine to not have this empty controlling only those three parts. So what you want to do, so this is a pick and choose kind of last option, only for the thing you don't really care to keep the empty controlling those last bodies. Look at here, the board and tube holder and the three parts inside. You can delete selected empty and reparent the children. So it just kills the parent empty, so there's no more empty here. And those 3 parts are now parented to the n+1 empty here, which may make more sense. Depends on what you want to do, what you need to do. So yeah, it's a very flexible system. Last, as we deleted a lot of empties, maybe what you want to rerun the fixed fusion just to change the scales of all the empties, because as we suppressed a lot of empties, obviously the scale of the whole cascade will change. Let's do it one more time. Obviously it's way more faster because we have less than half the part of what we had initially. So yeah, it's super fast. So as you can see here, those empties are really small. It means that they are quite a long way down the cascade. So you can see that the last one. Oh my god, I don't really know why the origin point is so far away from the object. But when you work with CAD data, sometimes that's the way it is. You have to work with that the best you can. So yeah, that's pretty much what it is. I hope you like it, and I hope my plugin will save you a lot of time, and thank you very much.